Okay, good afternoon, ladies and gentlemen. Okay, maybe we can start the parallel session for this afternoon. So we have 10 participants that will be present their material, their research in topic of chemistry. So we will have Mr. Hanif Amrullah. Mr. Hanif is here. Okay, then the second is Miss.
Yes, I'm here.
Okay, then Miss Nurhani Ariana, Mrs. Yadial Khalid, Miss Lintang Danasmoro, and Siti Oriza Sativa, and Mr. Miftahul Khoir, then Mrs. Nugraini Fahrunisa, Mr. Jasril, and Mr. Ihsan Ikhtiaruddin, and Miss Nahda Zafira. Okay, for the first presenter, we will have Mr. Hanif. So maybe the committee will play the video for us.
Assalamualaikum warahmatullahi wabarakatuh. I would like to thank to conference committee. My name is Hanif Amrullah. In this section, I would like to explain our project. It's about characteristics of nanosized magnesium oxide prepared using aqueous extracts of different parts of Moringa oleifera plant as green synthesis agent. Magnesium oxide is acknowledged as a multifunction oxide with an array of applications such as catalyst and catalyst support, absorbent for removing textile dye and heavy metal, antibacterial, and electrochemical biosensors. The magnesium oxide nanostructure is highly dependent on the synthesis method and condition. Many researchers have reported preparation of nanosized magnesium oxide using a variety of procedures such as precipitation, sulfothermal, steam chemical deposition, electrochemistry, sonochemistry, microwave, soil gel, and plant extracts. The plant-based green synthesis approach is increasingly popular because of its simple process, cost effectiveness, environmental friendly, commercial scalability, efficiency in large-scale synthesis, and flexibility in utilizing various value-added products. Moringa oleifera is one of the plants belongs to Moringaceae family that grow widely in many tropical and subtropical countries. Extract of several parts of Moringa oleifera have been used to synthesize metal compound, or metal oxides nanoparticle. This present work focuses on the synthesis of nanosized magnesium oxide using water-soluble compound extracted from different parts of the Moringa oleifera plant, including woody vascula, the bark of woody, twigs, and leaf. The physical characteristic of magnesium oxide produced were then evaluated using different techniques. Preparation of aqueous extract refers to the research by Elumalai et al. And Das et al. With some modification. Moringa powder sample of 4 grams were mixed with 100 milliliters of distilled water. The mixed one then heat to 60 Celsius for 20 minutes until the Moringa sample powder was completely mixed. The resulting filter was used as a stock solution for the synthesis of magnesium oxide nanoparticle. For each experiment, a fresh extract was used. The extract and then the total phenolic content in the total phenolic and flavonoid content in Moringa oleifera sample was determined by spectrophotometer. The phenolic content using Folin Shirkalti region with gallic acid as standard, and then total phenolic flavonoid content measure using colorimetric method with aluminum chloride as and catechin solution catechin as standard. The synthesis of magnesium oxide nanoparticle was initiated by adding 10 milliliter of extract into 10 milliliter of 1 millimolar magnesium chloride hydrate solution and stirring at 600 rpm at 90 Celsius. The precipitate format was spared from the mixture by centrifugation. There was and then was switched using ethanol. The wash precipitate was then dry using an oven to remove any residual water and ethanol. After drying, the precipitate was calcined at 600 Celsius for 5 hours. And then the synthesis of magnesium nanoparticle characterized using UV spectroscopy, X-ray diffraction, scanning electron microscopy, transmission electron microscopy, and particle size analyzer. Table 1 shows a moringa extract sample contain phenolic and flavonoid compounds. From this data, it can be concluded that all the moringa sample extract use contain phenolic compound which later function as reducing agent or chelating agent in the process of forming magnesium oxide nanoparticle. Flavonoid compounds such as flavonol, and tannin are secondary metabolites which are present in the plant. The antioxidant activity of this compound depends on the presence of free hydroxide functional group. Plant flavonoid compounds have antioxidant activity both in vitro and in vivo. In the middle image, synthesis of magnesium nanoparticle using moringa aqueous extract followed by change in the color during the synthesis process. The color of the solution changed from clear magnesium chloride solution to dark brown when added with moringa extract. After adding sodium hydroxide, the color of the solution changed to brighter, indicating the formation of magnesium oxide and magnesium hydroxide complex in the solution. In the middle figure, show the UV spectrum with a sharp peak at around 290 nanometer, which confirms the formation of magnesium oxide nanoparticle. The existence of a peak about 280 until 290 nanometer can be attributed to the formation of metal oxide nanoparticle after the addition of plant extract and sodium hydroxide solution. In the right figure, so the X-ray diffraction pattern of magnesium oxide nanoparticle produced from all moringa aqueous extract. A sample of magnesium oxide nanoparticles show the two peaks with highest intensity at 2 theta, 42 and 62, and then any 3 small peaks. The result obtained were verified using the GCPDS XRD standard data number 780430, and this result, no significant characteristic peaks appear from the magnesium or other impurities detected on the diffractogram, indicating the high purity of the synthesized magnesium oxide nanoparticle. This is result of scanning electron microscopy and transmission electrons microscopy and particle size analyzer. This figure shows that the resulting magnesium oxide nanoparticles are in the form of cubic sphere. The result of the particle size analysis show that the magnesium oxide with the particle size in the range nanometer with relatively narrow distribution was produced from the application of the 4-plant extract. The sample obtained using leaf and twig extract will have particle size in the range of 40 and to 80 nanometer, while those using wood and bark extract, the particle size in the range of 60 to 100 nanometer. The existence of the cubic sphere particle with a size range from 60 to 100 nanometer on this result was supported by the result of the transmission electron microscope. Based on the result, magnesium oxide nanoparticles have been successfully produced using aqueous extract of different parts of Moringa oleifera, providing an alternative method for synthesizing of magnesium nanoparticle. Based on the result above, it can be concluded that magnesium oxide nanoparticle was successfully synthesized using aqueous extract of different parts of Moringa oleifera as given engine. The UV phase absorption characteristic confirm the formation of magnesium nanoparticle. X-ray diffraction pattern indicate the formation of magnesium oxide structure. SEM and TEM image confirm the formation of cubic spheres. And then the particle size of the nanoparticle was found to be range of 40 to 100 nanometer. This result providing an alternative method for synthesizing magnesium oxide nanoparticle. Okay, thanks for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you for Mr. Awal Hanif, right? Mr. Hanif. Mr. Hanif. Okay, we can start the discussion.
Okay.
Yes. Okay.
Yes.
Our participant, please, if there is any question from the participant, please start your question. Yes, Miss Oriza Sativa, maybe you can start your question.
Yes. Okay.
Please, the microphone, the sound is very small.
How about this?
More, I think. Closer, microphone. Take the microphone closer to you.
And this?
Okay, Mr. Hanif, is it okay? You can hear the voice?
Okay, yes.
Yes, okay. Please go on, Mrs. Oriza Sativa.
Thank you, Dr. Hanhan and Mr. Hanif. I'm going to ask you questions. I saw on your presentation that leaf and twig extracts were found to have the particle size in the range less than bark and other part of moringa. Is there any reason why leaf and twigs has less size, particle size? I mean that 60, if I'm not mistaken, 60 to 80 nanometers. Is there any reason why leaf and twigs have that less particle size than other parts of moringa? Thank you.
Okay, thank you, Miss Oriza Sativa. For the reason why the particle size of magnesium oxide nanoparticle have the different size for the different parts is related with the content of total phenolic and flavonoid compound. This compound is usually used for the synthesis nanoparticle as a chelating agent, so that we in our project, and the twig and leaf extract is the highest total phenolic content, and then woody and the bark of woody is the less total phenolic content, so that this result is indicating that this compound is the reason why the particle size of the magnesium oxide nanoparticle is different. Okay.
Yeah, Mrs. Oriza Sativa, is it okay with the answer from Mr. Awal? I'm sorry, Hanif.
Yeah, I got the
Okay.
answer.
Is there another question? We still have maybe one or two questions. Still have time for one or two more questions. Okay, maybe I will ask you one question about the experiment. It is
Okay.
very interesting that you make the nanoparticle, right? About
Yes.
magnesium oxide and aqueous extract of the Moringa oleifera.
Okay.
My question is there any possibility to about the mixture of magnesium oxide nanoparticle to form salt with the phenolic compound in the extract? I think we know that magnesium oxide is like a base oxide, metal oxide that that show the basic properties, and the flavonoid contain phenolic group that acidic. So it's like possible to make a reaction, acid-base reaction there.
Okay. In literature, Mr. Okay. Okay, wait. The functional group in the phenolic or flavonoid content is can have the the mechanism is the ion of magnesium ion will be make a complex with the flavonoid or phenolic compound with their functional group, and then they will make a polymer with polymerization, so that this polymer will uh, make uh, this polymer is being the stabilizer with magnesium oxide, so that this with this stabilization, so the nanoparticle of magnesium oxide will produce.
Okay, so it's like supporting system in the reaction mixture that the formation of polymerization, right?
Yes.
It's like the
Yes.
support system in the reaction mixture. Okay, thank you,
Yes.
Mr.
Okay.
Hani, for a very interesting presentation. So
Okay.
now
Thanks.
I will invite the second presentation, Mrs. Nurhani, right? Okay, Mrs. Nurhani is here. So we can start to proceed to the presentation from Mrs. Nurhani.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhani Ariana from Research Center for Chemistry Review. Today I want to present our study entitled A Study in the Reported Estimation of Measurement Activities in Indonesian Proficiency Testing Scheme. The participation in the proficiency testing is a tool for monitoring validity of test results externally based on ISO IEC 17 or 25 and is mandatory for a testing laboratory which plan to propose accreditation status to the accreditation body. Recently, the importance of measurement uncertainty has increased in connection with accreditation, since it is mentioned in the clause 7.6 in ISO IEC 17 or 25. In proficiency testing, the most common method used to calculate the performance score is by the Z-score. This calculation does not include the parameter of measurement uncertainty. Research Center for Chemistry has organized annual proficiency testing since 2013, and in the submission of the test results, the participants were requested also to report the estimation of measurement uncertainty, but this is not mandatory, so the reported measurement uncertainties were used only for information and educational purpose. In our future TPs, we plan to also evaluate the participants' ability to have results equal to the assigned value within their claim uncertainty. So the performance score of participants can be calculated also by the Z score by including the parameter of measurement uncertainty of the test results. So the objectives in this study is to observe the reported measurement uncertainties, whether they were under or overestimated, and to investigate the cause of under or overestimated measurement uncertainties from the point of view of accreditation status of the participants, analytical instrument employed, and analytical method used. The methods in this study, we use the participants' data from 5 PTCs organized by Metrology and Chemistry Laboratory with test parameter cadmium in 3 different metrics: drinking water, wastewater, and reservoir, conducted from 2013 to 2016. The data will be evaluated by see the trends in estimating the measurement of uncertainty, by see the trend in accreditation status, instrument employed, and the analytical method used, and then the acceptance percentage between the Z-score and the Z-score will be compared. And this is the results. These are the graphs of the reported test results and their associated standard uncertainties. So the whiskers show the associated standard uncertainties for parameter cadmium in 3 different metrics. As you can see from the graph that some laboratories have underestimated uncertainties and some laboratories have a very long whisker, so they possibly have overestimated uncertainty. The ability of the laboratories in estimating the measurement of uncertainty can be affected by the accreditation status, the instrument employed, or otherwise analytical methods selected. From the accreditation status, from the data, you can see not all laboratories participated in the PTCs were accredited for ISO IEC 17 or 25. More than 79% of the accredited laboratories reported their estimation of uncertainties. Meanwhile, for the non-accredited laboratories, almost half of the total laboratories participated in the PT already have awareness on the importance of estimation of uncertainty, and the rest may not be familiar with it. These are the graphs. The graphs presenting the reported relative extended uncertainty group based on the analytical instrument and group based on the analytical method used. The analytical instruments commonly used by participants in measuring cadmium in selected metrics were gaseous spectrophotometry, flame atomic absorption spectrophotometry, graphite furnace, IAS, ICP-OAS, ICP-MS, and MPAES. From the point of view of the instruments used, as we can see in the graph, the standard uncertainties for high-risk errors, even when the participating laboratories use the same instrument. And the variation in the reported relative estimated uncertainties also appears, although the participants using the same sample preparation technique for the same test sample. However, in the report, most of the laboratories did not provide more detailed information about the approach used for estimating the uncertainties and their source of uncertainties. Therefore, we are unable to observe the impact of their approaches in estimating the uncertainties on the estimated uncertainty. There is a possibility that the participants have less awareness on the contribution of the concentration level of the measurement in estimating uncertainty. To assess how realistic the participants' uncertainties are, in this study, the data scores of the PT results were evaluated, and as a result, as you can see in the graph, over and underestimated uncertainties reported by some laboratories in comparison with the correlated standard deviation for proficiency assessment had clearly affected the data score. For our observation, although the participants achieved satisfactory results on the basis of the data score, the over and underestimated uncertainties caused a large deviation between the Z and the zeta scores that yield difference in percentage of satisfactory results, as shown in this table. Very low or high uncertainties can result in poor performance in the use of the zeta score or in the use of an individual criterion in calculating the Z score. So the conclusion in this study, a great variation in estimation of uncertainties corresponding with the PT results was found in the PTCMs conducted by Chemical Metrology Laboratory in measuring cadmium from 2013 to 2016. Some possible reasons that might cause this phenomenon are the laboratories do not have awareness of the different concentration level and the different methods of the measurement in estimating uncertainty, the choice of analytical methods, and carelessness in doing calculations. Over or underestimated uncertainties also cause a large deviation between the Z and the zeta scores. At this moment, the reported estimation of uncertainties cannot be included in the performance evaluation and only used as information purpose only. Capability in measurement uncertainty estimation can be increased by providing some related training to the participants. And that's all my presentation. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Well, ladies and gentlemen, please, if there is any question for Mrs. Nurhani Ariana. Okay, please. Well, yeah, okay. I think for chemists, it's like quite not very often we discuss about the uncertainty in measurement, right, Miss Nurhani? Okay, so in this study, actually you work for the Badan Meteorologi, I think. Okay. I'm sorry, I cannot hear your voice. Oh no, we couldn't hear you. No, we cannot. Do you use the earphone? Oh, maybe you can talk just put off the earphone from your laptop, or so you can. No, I mean you don't need to talk with the earphone, I think. Yes, okay. Yeah, I can hear something from there. Yeah, maybe closer to the microphone. Yeah, okay. It's better now.
So previously, the methodology chemistry laboratory is under one for technical laboratory. Now, for technical laboratory,
Yes.
has to include also
Okay. So yeah, I need to ask you about about the uncertainty here. So the Z score and zeta score, I think it's very related, right? Okay. So in this test, how we could make it sure that that zeta score can substitute the Z score for each experiment.
we have different functions. For the
Hmm.
this score only calculates the performance based on the technical of the so we want to see the performance of the batteries based only on the technical.
Yes.
While for the data score, we want to see the performance of the battery based on the ability to calculate the measurement activity. So it's different functions.
Okay, but it still can but it's very related, right? Between Z score and zeta score, right? Okay, and maybe another question from the audience here, please. Okay, maybe I have another question because I think it's very interesting for us to gain more information about the measurement uncertainties, because it is very important because something we should make a validation about the methods, right? Okay, and my last question is there any what's this like noise about it in some measurement we sometimes get noise, right? Okay, how we could overcome the noise in maybe like the measurement of cadmium here. Is it any problem with the Z score or zeta score from the noise in measuring cadmium?
When we only see the performance of like score, most of the laboratory have power and there is no handle with
Okay. Okay. Thank you, Mrs. Nurhani, for the information. Very interesting. Maybe I once will send you an email about this. Okay. Okay. Thank you. Maybe an other participant we can also contact the presenter here by the email that written on your book of abstract. Okay. Thank you, Mrs. Nurhani, for the very nice topic. So we can continue to the next question. I mean to the next presenter from Miss Anna, Mrs. Anna. I'm sorry, or Mrs. Sri. I don't know who is the presenter for the abstract number 31. Okay, Mrs. Sri. Okay, Mrs. Sri. Please the video.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, moderator, giving me this occasion to do our presentation. I would like to introduce myself. My name is Riyadil Khalid. The member of our team, Anna Mawana, Siti Nurbaiti, and Widiani Maisa Utami. We are a lecturer and researcher from the Chemistry Department of State Islamic Sharif Dayatullah, Jakarta. Today, I am going to present our research entitled Characteristic and Antioxidant Activity of Kidney bean tempeh as Functional Food. Introduction. Kidney beans are widely cultivated and produced in Indonesia was highly. Meanwhile, the application as food still limited, such as vegetable kidney bean paste and making cookies, so it needs an alternative way to process kidney bean. In this paper, we have processed kidney bean into tempeh and determined their functional properties as sort of antioxidant. According to Orak et al., the functional characteristic of kidney bean as antioxidant is performed by phenolic compound. Method. Making tempeh. For making tempeh consists 3 stages. The first, soaking. The second, boiling and drying. The third, fermentation using tempeh yeast with variation 0.2, 0.4, 0.8, and 1%. Organoleptic test. The organoleptic test was performed by 36 semi-trained panelists. Panelists was asked to observe texture, mycelium color, and the smell of tempeh. The panelist was asked to give an opinion by filling the form. Kidney bean tempeh extraction. Kidney bean tempeh was crushed by blender and we measured it with 250 mm methanol PA and stored for 24 hours. Then was filtered to get residue and filtered. This procedure was done twice. The filtrate was concentrated by using rotary evaporator to obtain the kidney bean tempeh extract. Antioxidant activity test. We dissolved red bean tempeh extracting by using methanol. Then extract was made as series 500, 250, 125, 62.5, and 30.25 ppm. 2 ml this sample was added with 2 ml DPPH solution and then incubated for 30 minutes. The absorbance of sample was measured by spectrophotometer and then we calculated the IC50 value. Total phenolic and flavonoid content. Total phenolic content was determined using volume and the total amount of flavonoid by using aluminum chloride solution. The approximate analysis. The approximate analysis was as protein and fat. The parameter content was performed by AOCA method. Result and discussion. Characteristic of kidney bean tempeh. We found the kidney bean tempeh had a solid texture, odor, and different color for each varied concentration of yeast. Tempeh was produced with the yeast concentration 0.2 and 0.4%, figure E and B, had unsolid texture, and the mycelium doesn't spread on the soft, therefore the texture was fragile. Figure C was tempeh produced with 0.8 yeast. So the tempeh was clearly seen, the white color evenly spread of mycelium. Tempeh D was made with 1% yeast. We can see the solid texture evenly, but odor is not like tempeh, give off unpleasant odor. Organoleptic test kidney bean tempeh. We can conclude that the red bean kidney bean fermented using yeast with by 0.8% are preferred for texture, odor, and tempeh density. Kidney bean tempeh antioxidant activity. Kidney bean tempeh fermentation could improve the inhibition activity of DPPH radical table 3. Inhibition activity of kidney bean was 60.02%. The result was not much different from the result obtained by Zhou et al., but the done extraction and isoelectric paint method. Inhibition capability of TMPD was declined as many due more number of microorganisms in yeast. So the nutrition component were utilized as energy source and reducing antioxidant activity. Then we calculated the IC50 table 4. Total phenolic and flavonoid content. Kidney bean are sourced as secondary metabolite such as flavonoid and phenolic. The compound have functional as antioxidant. The result can see on table 5. We can see total phenolic and flavonoid content of kidney bean tempeh was increased compared with the kidney bean. In our opinion, an enzymatic hydrolysis reaction occurs during fermentation and break down glycoside bond. The result kidney bean tempeh proximate. The proximate tests are presented in table 6. The water content in tempeh C was increased from the process of soaking and boiling. The S content of tempeh was lower than kidney bean. Some essential mineral utilized by microorganisms as mineral salts. The fat content of kidney bean tempeh was lower than kidney bean. This indicates that fermentation could increase the fat content. The protein content of kidney bean tempeh was slightly lower than kidney bean. Decreased protein content may due they were utilized by microorganisms as energy source. Conclusion. Fermentation could increase antioxidant activity and secondary metabolism in kidney bean. Acknowledgement. We say thank you to Director Win Syarif Hidayatullah, Jakarta. Thank you, moderator. And I say, wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for a very informative presentation from Mrs. Sri Chalit, right? Okay, ladies and gentlemen, please, if you have a question for Mrs. Sri. Any question for Mrs. Sri, please? Yes, Mr. Hanif, you can start your question. Yeah.
Okay, thank you, moderator, for Miss what I done. Okay, my question is: have you studied the antioxidant from soybean tempeh or from the literature to compare it with this tempeh from kidney bean tempeh to compare the antioxidant, and so it to find out the advantage of the kidney bean tempeh? Okay, thank you.
I will to try answer your question. Number one, I think functional food as soybean, tempe, higher antioxidant than tempe come from kidney bean. I think that, and I think for the work for the next time we will go to our team. I think my team will done tempe, kidney bean tempe as some functional food, as anti-diabetes, anti-hypertension, and then today my student and my teams are going to do as antioxidant and as anti-hypertension, and we can make a product like biscuit or the other, and the mie kering atau mie basah. I think is it enough? Thank you.
Mr. Hanif, is it okay? Or you can ask more questions?
Okay, I think enough.
Okay. Any other question for Mrs. Sri, please? You can start to open your microphone and start to ask Mrs. Sri about the presentation. Okay, I think I still have more question for the audience, for the presenter here. Mrs. Sri, I need to ask you about the tempe. In this experiment, which part of tempe that you use to be extracted? Is it just you pick the fungi, or you just put the tempe, all of the tempe, the fungi and the bean in, so you extract all of them, or how you could have the extract?
Okay, I will try to answer your question. We extract all of the tempe, include yeast. But before we do extraction, the yeast we could by sterilisasi to ungrowing the yeast.
So you how you stop the growth of the yeast by how you
by heating.
Okay, by heating. So you heat the tempe, whole of tempe, and you extract the tempe, right? Okay.
Before we extract, we blender, we distract tempe by blender. Then
okay. I think it's very interesting if you can continue to the organic molecule study of the kidney bean tempe. I think it's very new and interesting. Thank you.
Yes, thank you, Mr. Hanan, to your suggestion.
Yeah. Okay, thank you. Very nice presentation and discussion from Mrs. Sri. We can give her applause, maybe virtually applause. Okay, thank you. We can proceed to the next presenter. We will have Miss Lintang. Miss Lintang, are you ready for your session? I think.
Yes.
Okay, we can start to watch the video of your presentation.
Assalamualaikum warahmatullahi wabarakatuh. In this occasion, I would like to present my research entitled The Effects of the Applied Potential of Square Wave Deposition Technique on Electrochemical Properties and Photocatalytic Activity of Bimetallic IGBT. Before we begin, let me introduce myself. My name is Lintang Danasmoro. I'm from Chemistry, Universitas Negeri Jakarta. Okay, let's start the presentation. Dipollutants that release into the environment is continuously able to inhibit sunlight penetration into the water and will disrupt the leaves of aquatic plants. And one of the most common dyes that contaminate nature is methylene blue. Methylene blue is a lateral hydrocarbon which is frequently utilized as a textile dye and chemical materials such as indicators. Metal and glue that are continuously discarded into the nature are harmful and difficult to degrade normally, thus become a major issue for the earth and well-being. So, one effective solution to handle wastewater, particularly the wastewater, is through a photocatalytic degradation utilizing photocatalysts and UV light. So, AGPT nanostructures are one of the materials that demonstrate remarkable enhancement of photocatalytic activity because of their anisotropic properties and have steadier characteristics than its monometallic. But due to their extraordinary thermodynamic immiscibility and reduction kinetics, it's generally difficult to be prepared because of segregation phenomenon into peri-rich and age-rich phases often occurs. So there are a lot of methods to prepare HPD, such as hydrothermal and physical vapor deposition, chemical vapor deposition, also electrodeposition. But these were used electrodeposition because it has simple procedure, great cost efficiency, and high purity of the resulting materials. But the previous works, a study of the effect of applied lower deposition potential and its correlation towards electrochemical properties of HPD is still lacking. Therefore, this work tackled the influence of the electrodeposition potential on the electrochemical and photocatalytic properties of HPD. And the focus of our work is to enhance its photocatalytic performance of the metallic HPD by differing the applied lower potential and examining the electrochemical properties such as specific capacitance and impedance value, which may play a role in cost effectiveness for practical application. And next is synthesis procedure. Here you can see the synthesis procedure for bimetallic AG preparation and photocatalytic activity. Okay, next is the result. Here's the result of semi-micrograph of the morphology of AGPD at lower deposition potential, or ELO, and minus 0.5 volt. You can see that the image exhibits very small clusters scattered over the substrate. And then figure 1b shows the EDX spectra for the AGPD at ELO minus 0.5 volt. And it shows that the composition of the AGPD have weight percentage of 36 and 63 respectively. Next is impedance testing. So on the left side, the Niki's plot gives an ascending trend in the equivalent series resistance, or RS, as follows. And a low RS value shows great conductivity because of the low internal resistance of the cathodes. This can promote electron transfer process effectively, so it could enhance its photocatalytic activity. And the lowest value of RS is gotten at HPD with ELO minus 0.5 volt, indicating that the layer can improve the electrolyte ions division due to its higher electrical conductivity. Next is capacitance testing. From the figure on the left side, it shows that the specific capacitance value slightly decreased with the addition of scan rate. And here we use 3 different scan rates. And slow scanning rate allowed the electrolyte to penetrate the material pores more thoroughly and increase contact with the electrode surface, producing a greater capacitance value. At higher scanning speeds, positive ions in the electrolyte can only approach the outer surface of the electrode, resulting in a smaller capacitance value. And here, the highest calculated specific capacitance can reach to 24.3 farad per gram at the scan rate of 10 millivolt per second was obtained when the lower potential deposition is minus 0.5 volt. Next is photocatalytic activity towards methylene blue degradation. From the figure, we can see that the highest value was obtained at the lower deposition potential of minus 0.5 volt, and 19.16% of the methylene blue had degraded after 30 minutes of UV irradiation. This phenomenon should be related to the lower RS value, since they are the smallest resistance, so that the load transfer in the material is faster, thus resulting in greater specific capacitance value, that is as high as 24.3 farad per gram. And next is the conclusions. So, IGPD has been successfully synthesized by electrodeposition technique using square wave. Bimetallic IGPD with lower potential minus 0.5 volt proved to have the best photocatalytic activity against methylene blue degradation, which was as high as 19.16% in 30 minutes under UV radiation. This is the implication of the low resistance value, so it could enhance the electrical conductivity of the material, thus creates a faster charge transfer and resulting in higher specific capacitance, thereby increasing its photocatalytic activity. And it may be concluded that the photocatalytic degradation was found to be dependent on the lower potential of the material. So that's all my presentation. If you have any question, please kindly ask me. And Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. And now we can start the question and answer session for Miss Lintang, please. Is there any question for Miss Lintang?
I want to ask Miss Lintang Danesmoro.
Yes, please.
What makes you choose bimetallic AGPT as a photocatalyst? Thank you.
Okay. Okay, thank you for your question. Can you hear me?
Yes, please, Miss Lintang. You can start your answer. Yeah.
Okay, yeah. So I choose bimetallic IGPT because it has the potential as a photocatalyst. Because we know that Ag has the highest visible light absorption ability among other metals, while PD has also good catalytic efficiency in various organic reactions. So the combination of Ag and PD metals have a difference in electronegativity that encourage electron transfer, thus will enhance its photocatalytic activity. I think that's all my explanation. Thank you.
Okay. Miss Nahda, is it okay? Is it enough, or you still have another question?
Enough here.
Okay, thank you for Miss Nahda. So, is there any other question from the audience? Okay, Miss Lintang, I think we still have, we can still have time for one question. Yes, please, Miss Oriza Sativa.
I have a question to Miss Lintang. Because we got in the same research area, which is photocatalysis. I just want to confirm here. You use a UV light source to initiate the photocatalytic reaction, right?
What? Pardon
We
me?
use the UV light source to initiate the photocatalytic reaction.
UV light.
Yeah. May I know, I just want to confirm here, may I know the wavelength of UV light source you use, or do you use a filter to the specific wavelength? Because UV light source has a range to, from 100 to 400 nanometer, if I'm not mistaken. Thank you.
Okay, for my experiment, the UV lights didn't have filters, and it consists of 5 UV lamp. Yeah.
That's okay. Thank you.
Okay.
Okay, so Miss Lintang.
Yeah.
Okay, so you just start your UV lamp without any filter, right?
Yeah, that's right.
So I think maybe for the next research for your next research, I think it's better if you know the wavelength of your UV lamp. Yeah, so we can also measure the optimum condition about your irradiation, I think.
Oh, okay.
Yeah,
Thank you for
I think
your
that's just my
suggestion.
suggestion. Yeah, because for the reaction we know that the each reaction, especially for the photocatalytic reaction, there's must be minimum energy for to start the reaction. Yeah.
Yeah.
Okay. Yeah, and
Okay, all right.
yeah. Okay. Thank you for Miss Lintang. Very nice presentation. So next we can start Miss Oriza Sativa to start the presentation. Operator, please.
Okay, ladies and gentlemen, first of all, I would like to say thank you to the committee for holding this international conference. And allow me to introduce myself first. My name is Siti Oriza Sativa, and I am the presenter of ABS 47, along with other researchers, Muhammad Ali Zulfikar and Anita Alni from the Department of Chemistry, Institute of Technology Bandung, Indonesia. And today, I'm going to present our research titled Optimization of pH or Potential Hydrogen and Radiation Time for Photocatalytic Activity of Methyl Orange using titanium dioxide.
Okay, maybe there's like a problem in the video playing. Oh, it's still
Okay,
going to the video.
textile industry requires a lot of water in the process of manufacturing. This process produces byproducts from the liquid waste of industrial process. Improper waste treatment can cause problems for the environment due to its toxic nature. A study shows that 15% of dyes are lost during the coloring process and became liquid waste. Methyl orange is an organic compound that used in many coloring industries as well as textile industry. There are several ways that have been done in treating dyes waste, such as biological processes, absorption by activated carbon, and also coagulation. But here we chose photocatalytic degradation. Photocatalyst is a material that is useful for the degradation of pollutant compounds. There are many materials that can be made as photocatalysts, especially semiconductor materials such as titanium dioxide. Titanium as a photocatalyst for the degradation and removal of organic pollutants and dyes has been relatively inexpensive, very efficient, high stability, and low toxicity. And titanium dioxide compound can be synthesized by sonochemistry, hydrothermal processes, hydrolysis under acidic condition, or sodium methods. But here we chose hydrothermal method. So here is the experimental method in our research. A total of 15 milliliter of 10 ppm methyl orange solution at pH 5, 6, 7, 8, and 9 put into the breaker glass, added titanium dioxide, put breaker glasses inside photoreactor system, stirred under dark condition for 20 minutes, irradiated under 30 watt UV light sources, and determine the remaining of methyl orange solution by using UV spectrophotometer with the lambda maximum is 467 nanometers. So here you may see that this is the photoreactor that we use in our laboratory. So we are going to the result and discussion. Before determining the working pH range, the maximum wavelength of the methyl orange solution was determined at pH 2 to 9. This was done to know which potential hydrogen approach the wavelength of the methyl orange solution, which is 467 nanometers. And the table 1 shows that each maximum lambda with each absorbance that we already studied at the range pH 2 to 9. And we don't count the pH of 2, 3, and 4 because of the maximum lambda is far from the lambda maximum of methyl orange solution. And then here we are going to the optimization of pH and radiation times. Figure 1 shows the optimization of pH of titanium dioxide photocatalytic activity. And the figure 2, the optimization of radiation time on titanium photocatalytic activity. You may see here that the pH of analyte solution, which we use the methyl orange solution, can be determined the rate of photocatalytic activity of titanium dioxide. And then at the pH 5, the highest percentage of degradation was found, as in slightly acidic atmosphere, will increase the number of radical OH intermediates because the reaction rate of photocatalytic activity is greater. And the result is the optimum pH is 5 in this research. And then we jump into the optimum of radiation times, and here the determination of optimum radiation time of photocatalytic activity of titanium dioxide was carried out by varying the radiation time for 1 to 9 hours. From the result, the optimum contact time to degrade the methyl orange solution is 8 hours. So here, 8 hours. It's a 100% degrade. And then it can be concluded that the longer radiation time, the degraded methyl orange solution will also increase. This is due to the longer irradiation time, there will be a lot of radical hydroxide that accelerate the photocatalytic activity of titanium dioxide. And percent degradation of methyl orange when exposed to the UV light for more than 8 hours is relatively constant. So you might see here the difference between 8 hours and 9 hours as not that longer. This shows that between 1 to 8 hours of interaction between UV light to titanium dioxide and metal orange sunlight, the greater the degraded metal orange. But physically, this could be seen from the change in the color of the solution from orange to the colorless. So here is our conclusion. Photocatalytic activity of synthesized titanium dioxide by using hydrothermal method for the degradation of metal orange solution had been carried out. From the result of the study, it was found that the pH optimum was 5 and the reduction time was 8 hours. So here are our references, and thank you. If you have any questions, suggestions about our research, we are looking forward to it. Thank you. Have a good day.
Okay, thank you for the presentation from Ms. Oriza Sativa. So now I invite all of you to deliver the question, I think. Okay, Mr. Hanif, please start your question.
Okay, thank you, moderator. Miss Siti Oriza Sativa.
Yes,
Hello?
go on. Yes, go on.
Yeah.
She can hear
I
you.
think the band gap. I think the band gap energy value is generally needed in studying the photocatalytic process. Did you calculate the band gap value of titanium oxide?
Is there any question, sir?
I think the band gap energy value is generally needed in studying photocatalytic process. The band gap energy. Did you calculate the band gap value of titanium oxide so that we can relate this with to its photocatalytic activity? Okay.
Thank you. Should I answer the question, Dr. Hantan?
Yes, go on, please. Yes, please.
Thank you, Mr. Hani, for the question. Do you hear me clearly?
Yes,
Okay.
yes.
Okay.
Yes, of course, we calculated the band gap, the energy band gap of titanium dioxide that we synthesized. But in this research, as the solvent is water, the band gap is 3.0 electropholt. We count it by using the UV spectrophotometry. Yep, the band gap is 3.0, and the solvent is water. Thank you.
Okay. The effect of pH with the band gap energy value.
There are effect band gap energy to the wavelength that UV light source that we use. So the greater band gap energy, the lesser wavelength light source that we use. So here, as the count of band gap in our research is 3.0, that's the reason why we use UV light source as the to initiate the photocatalytic reaction. If in our research we found the band gap energy less than 3.0, we may use it. We may use a visible light source. We just put the photocatalyst and the analyte under the visible light source, and then the degradation happens. That is the yeah, that's it. Sorry.
Okay. Do you display your band gap data in your manuscript? I think this is very important.
Pardon me, sir?
Do you display your band gap data in your manuscript?
Oh, no. In this manuscript, on this full cover, no. We only focus on the photocatalytic degradation.
Because I think this is very important to describe your data.
Oh, okay. Thank you for the suggestion, sir.
Okay.
Okay. Mr. Hanif, still have another question?
No,
okay.
I think.
Yeah. Okay, another question from other participants here, please. Miss Lintang, I think you have the same subject in research with Miss Siti Oriza Sativa. You can discuss about your research after this, I think, between Miss Lintang and Miss Oriza Sativa, right? It's very interesting if you can build a new collaboration or new connection between the participants in a conference. Okay, thank you, Miss Siti Oriza Sativa. Miss Siti Oriza Sativa, thank you for your presentation and very good discussion. So now we continue to next presenter, Mr. Miftahul Khoil.
Yes, yeah, I'm here.
Okay, we will play the video of your presentation and we can start the discussion.
Okay.
Yes, please.
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, thank you so much for giving me this chance for speaking in front of you about my project. And the title of my presentation is Green Preparation of Activated Carbon from Palm Oil Trunk by Microwave Assisted Activation. And I'm from Chemistry Department, Universitas Negeri Padang. In the introduction part, I would like to remind us something we are very familiar with. It is palm oil, and it is produced from palm oil tree. And what I'm concerned now is about their palm oil waste. Actually, there are many parts of the palm oil trees which have not good economic value after producing palm oil. For example, maybe what I'm doing now, I used to explore the potential benefits of the palm kernel cell, also from the oil palm trunk from the tree here. And this is palm oil trunk, and this is the cross section of the palm oil trunk, and this is the subsequent part, and it's the trunk. The components of this trunk is like this one. As you can see here, there is lignin, cellulose, hemicellulose, holocellulose, pentose, and water. And this is the constituent of palm oil trunk. And also, if we see the structure of the chemical here, like lignin, cellulose, and something similar like this one, and most of them are constituted of C atom, carbon atoms. So actually, we can extract the C atoms from all the hydrocarbon materials here in order to get something called activated carbon later. This is the activated carbon. So activated carbon, we used to use this material for many purposes, like for adsorbent, for filtering water treatment, adsorbent. And in terms of chemistry, it is made of graphite. So activated carbon can be graphite, like this one. Is constituted of elements of graphite, and maybe it can be very amorphous or graphitic. And the interesting things from activated carbon is that activated carbon has very large surface area, 300 up to 4,000 meters square per gram. And of course, by seeing the structure, we can expect that this material can be very potential for absorbent. And for using activated carbon for many purposes, especially for water filtration, Indonesian national standards have make a requirement for all the items for activated carbon. For example, water contents, it must be less than 15%, ash content, it must be less than 10%, volatile matter, it must be less than 25%, and fixed carbon, must be at least 60%, and iodine absorption, it must be at least 750 milligram per gram. How to make activated carbon? Basically, there are three principles. It's dehydration, we burst, and then we perform carbonization, mostly by using heating, by using a furnace, which limited input of oxygen, or pyrolysis, or by using inert gas like nitrogen. And after that, there is something called activation. And from carbonation material, we get carbon here. We have to activate the carbon so that it can be named as activated carbon. For performing activation, we used to use chemical activation and physical activation. Chemical activation by adding chemical like acid, base, and salt can be used transforming the carbon material into the activated carbons. And also by physical activation, maybe by heating and so on. Let us now discuss the use of activated carbon for water filtration. For making activated carbon, all the material containing carbon can be used for producing carbon. And for example, we have rice husk, coconut, and also bones. When we discussed the use of activated carbon for water filtration like this, so it is critical for the source of the activated carbon here. If some producer used to use cheap pork bones for producing activated carbon, so this cannot be halal in terms of Indonesian undang-undang GPH compliance and also for Muslim consumption. So our intention now is how to produce low-cost activated carbon from the waste of palm oil so that we can overcome the expensive production. Now we will use microwave heating for activating carbon. This is a microwave oven. This is the generation of microwave inside the oven. And what is microwave? Microwave is the electromagnetic wave consisting of electric field and magnetic field propagating together. And if it interacts with a polar molecule like water, and it will rotate, it will move, and this movement will generate heat. Heating by microwave is also good in terms of green chemistry aspect. For example, waste prevention, less hazardous synthesis material, inherently safe chemistry. So this is my project overview. We will use all the waste from the palm oil tree, and we will make activated carbon by using activating agent, microwave, and all other green method for activation, and in order to get absorbent for water filtration. So objective of the current research is to prepare low-cost activated carbon from palm oil trunk waste with no chemical addition. This is the method. There are 3 steps in preparation of activated carbon: preparation, carbonization, and activation. From palm oil trunk, we will cut into chunks, small parts, and then we will dry. And then this is the sample which is ready to be carbonized. And then we will heat, and we will use 400 degrees Celsius for 19 minutes carbonization. This is the optimum value after some experiments. This will be let to cool by standing for 24 hours. And then we will shift with 100 mesh, and then we will get fine carbon. Still, it is only carbon, not activated carbon yet. Then here we will perform proximate analysis and also FTIR measurements and XRD measurements, and then we edit with aqueous because we will use microwave. So aqueous is very important for generating heating. After edit aqueous in some amount, so then the sample fine carbon is put in the microwave, and the microwave is run for 5, 10, 15, 20, 25, and 30 minutes, and then we will see the trends and we will get the optimum value. And then we will wash, dry, and then we perform again proximate analysis, also the characterization. This is the result. This is the sample, our fine carbon after carbonization. And this is the table containing the SNI standards for activated carbon. That is the rendezvous time, and also carbonization time for the 60 minutes is very good enough. And I think it's good for us also because we do not need much time for performing carbonization. For moisture content, all the value here are below the required number of SNI. So it is enough, it is good because all of them are less than 15%. The ash content, we can see here all of most of them are below the required SNI standard, so it is good. But the best one we can see here is at this blue one, at low temperature 250 degrees Celsius and for 60 minutes carbonization. And in volatile matter, carbonization at 60 minutes and low temperature 250 degrees Celsius is also good, and the volatile matter is also still under the required maximum number of SNI. And in the fixed carbon, we see again at 250 degrees Celsius, the blue one here is the best one. The problem is arising from the iodine number. All of them, all of the treatment here for carbonization do not fulfill the value for activated carbon. So it is not activated carbon yet. So that we need to do activation for making this carbon activated and can be used later for assessment. This is our sample after activation. This is the rendezvous. The content of water is still under the required maximum number of SNI, so it's okay. And all of the values for ash content is also under the required maximum number of SNI, so it is good. The volatile matter, they are also still under the required maximum value of SNI, so no problem. Now for fixed carbon, all of them are good because they are more than the expected value of SNI. It lets us focus on the iodine number because our sample will be used for adsorption data, so the adsorption capacity can be determined by iodine number. We have at this point our sample can be said that it's already now activated carbon. Let us focus on the iodine number. So iodine number reflects the adsorption capability of our activated carbon. Some of them are below the expected value, but there is some of them which are above the required value by SNI. For example, this point, then we can say that at this point we have already now the activated carbon needed. Optimum microwave activation happened at 4,150 watts and 30 minute irradiation of microwave. We have already obtained activated carbon, and then we would like to see what happened with the structure. The XRD peak, this is the XRD peak of our sample carbon inactivated carbon, and for this you can see that it is already graphitic crystalline activated carbon was already prepared. And if you compare with the carbonization, after carbonization, the peak this one is much more smooth, so that we can say that some of impurities is only removed after activation with microwave. And we come to the conclusion, reactivated carbon was successfully repaired based on SMI standard from palm oil trunk by carbonization at 250 degrees Celsius for 60 minutes, followed by microwave activation for 450 watts for 3 minutes only. Okay, we have already tested this microwave by lead ion absorption, and we got this maximum absorption of 3.18 milligram per gram. But the conclusion is not here. And finally, we acknowledge University Padang for the funding this research via PNBP grant year 2019. And it's a supplement for my calculation of all the moisture content, ash content, volatile matter, and so on. And thank you so much for your kind attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Yeah, and now I invite you to start a question for Mr. Miftahul Khair, please. Is there any question?
I have a question.
Yes, please, Mr. Ihsan.
Okay, thank you for Mr. Hanhan. I have a question for Mr. Miftahul Khair. What irradiation power does you use for activation process in your work?
Thank you so much, Mr. Ihsan. Actually, it was mentioned in the last slides. It is around you can read around 300 watts. Yes, around. Did you see my slide? I didn't memorize the number. Let me check. 450 watts.
Or?
450 watts.
Oh, okay. Thank you,
yes,
Mr. Miftahul.
Yes.
Thank you, Mr. Hanhan.
Yes. Okay. Is there any other question for Mr. Miftahul Khair here? Okay. I will ask Mr. Miftahul Khair here.
Yes,
it is very interesting to explore the utilization of the local resources, right?
Yes.
Now, yeah, I think in Padang we have many palm plants. Yeah.
Yes.
So the one I want to ask is about the activation of carbon. He said that you put the carbon in water and then you start to microwave.
Yes.
To microwave the mixture. So is it common to activate carbon in water? Right? Because as I know, as I know, we usually activate carbon in like heating or something.
Yes. Yes. Thank you so much, Mr. Hanahan. Yes, actually, carbon is not dissolving in water. It doesn't dissolve, of course. But the function of water here is just to provoke the heating, because we need polar materials which are able to interact with microwave, so that heat will be generated after the movement or rotation of the polar molecules. And this is this role is taken by water. So that's why water is very important for making activation of microwave. So there's no chemical reaction actually. It is only physical activation there's no reaction at all.
Oh,
But we get benefit from the microwave radiation from water heating.
Yeah, because it's very new for me to know that
Yes.
that methods to
Yes.
activating carbon. So
Yes.
I think it's safer than we hit
Yeah.
the carbon. So because
Yes.
something I oh, my carbon burned like that. Yes, I experienced I hit the the carbon to be activated, but I got the carbon burn.
Burn to give CO2, I think.
Yeah,
Yeah,
okay.
CO2. But
Okay.
there's water there.
Okay,
So that there's
and
no interaction with oxygen.
yeah, and I think your methods is very fast because the use of microwave heating.
Yes.
So I think I will try your method.
Thanks so much. Thanks so much,
Okay.
Mr. Han.
Okay. Thank you,
Thanks so
Mr.
much.
Mr. Hoy, for very informative presentation for
Thanks so
this
much.
afternoon. Okay, now we can give applause for Mr. Hoy virtually, of course. And we have next presenter, Mrs. Nugraini Fahrunisa. Okay. Yes. Please, ladies and gentlemen, we proceed to the video of Mrs. Nugraini Fahrunisa presentation.
Halo, Assalamualaikum warahmatullahi wabarakatuh. My name is Nugraini Fahrunisa. This time I want to give presentation about my paper. The title of my paper is Mechanical Properties Improvement of Bacterial Cellulose Film by Thermohydromechanical and Electrochemical Treatment. Bacterial cellulose is one of the most interesting material. They has considerably higher purity, hydrophilic, higher crystallinity, and degree polymerization up to 8,000. These characteristic properties make it an attractive candidate for a broad range application in various fields. And to produce bacterial cellulose, we can use culture medium, and there are several culture methods that already used, such as static culture, agitating or shaking culture, and bioreactor culture. Cell culture conditions such as bacteria strain, nutrition, pH, and oxygen supply were crucial and affected for bacterial properties. And choosing culture method that we can choose for produce the bacterial cellulose, we can choose depend on the purpose of the bacterial cellulose. And for improving the properties of the bacterial cellulose, we can use treatment and choosing appropriate drying method. These two treatment can affect on impurities and the porous structure of the bacterial cellulose. We choose the static culture as the culture method. The medium that we use from coconut water with sugar and acetic acid, and the acetobacterium as the bacteria. The medium was boiled and stirred for 1 hour, and we cooling them until reach the room temperature. After that, we pour the acetobacterium into the medium solution. After that, the acetobacterium solution was inoculated for 14 days. After 14 days, we harvesting the bacterial cellulose, and the bacterial cellulose was soaked in salt water within a concentration of 3.5% within 24 hours. After that, we dried the bacterial cellulose using hot press on 150 degrees Celsius for 1 hour. After that thermal treatment, the bacterial cellulose was pressed at 1 megapascal pressure for 15 minutes. We use Fourier transform infrared and stress testing ASTM F1670 for characterization our bacterial cellulose. And the result that we get, we look at the effect of salt on intercellulose hydrogen bond. We choose 2 point interest from IR absorbance at wave number 3340 and 3275. And this is the illustration. This is the illustration of cellular structure. These two graphs can describe that the result that we get for IR absorbance at the wave number 3275. There are no different or just little different the number of absorbance between these two bacterial cellulose. And at the wave number 3340, there are big difference at the absorbent number. The absorbent number of bacterial cellulose treated by salt water are higher than the bacterial cellulose that untreated. And the improving of the absorbent numbers at the bacterial cellulose treated by salt water was indicated that the hydrogen bond could be formed at this point of interest. From the simulation body fluid, the bacterial cellulose that we produce were able to withstand until 20 kilopascal load for 30 minutes. The conclusion from this report shown in brief potential of bacterial cellulose as non-woven material for personal protective equipment. So this is all that I can give explanation about our paper. Thank you for the time. Stay healthy. And wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for Mrs. Nograni for the very nice presentation. So now I invite you to start the discussion with Mrs. Nograni. Is there any question, please? Okay, if there's no question, I will ask Ms. Nograni. Yeah, the film from natural resources now is very what's that? Very happening. Yeah, many researchers start to improve the natural film, I think. So now from your research, is it possible if we use the what is this? The cellulose film for plastic substitution, I think. Is it possible?
Plastic since like the bacterial cellulose in market we if the plastic substitution like maybe plastic from cassava. Yeah, that's the example. It's already we use many. I think many shop already use like plastic from cassava, and our government already minimize from using plastic. So there is bacterial cellulose like one of options.
Okay, so yeah, so it's right. We can choose the cellulose film for the plastic substitution.
Yeah.
And yeah, and for from your presentation, actually for what mechanical properties that we could what mechanical properties that other bioplastic uh, couldn't be uh, couldn't be couldn't be good. I mean, for the substitution of plastic, what the cellulose film have that other biofilm doesn't have? Okay. That's my question.
Okay. Our what is this? We want to approach that the new properties or approach like we want to make a new material for replacing the material already used for several years and already used for our industry. So literally this material we want to make as a replace material
or plastic.
Yeah, one of material like plastic or like something that material we can produce our own country, so we don't have to import from abroad. So one of the properties is like we don't want to stiff but not brittle.
Okay.
Like yeah, something like that. That we want to approach like a good composition to approach that something properties like that.
Okay. Yes. Is there any question from other audience here? Please, for Miss Nugrani. I think this is the bacterial cellulose is very have many advantages for future plastic substitution, I think. Okay, thank you for Mrs. Nugrani for the presentation, and now I will continue to Mr. Jasril.
Okay.
Yeah, okay. Pak Jasril, right? Yeah. Okay, now we can start the video of Mr. Jasril presentation, please.
Good afternoon, ladies and gentlemen. Thanks to moderator and all committees of the Second Science and Mathematics International Conference 2020 for the time as given to me. I am Jasril from Department of Chemistry, Riau University, Pekanbaru. Today, I would like to present our research entitled Microwave-Assisted Synthesis of a Fluorinated Pyroxylin in silico study and in vitro cytotoxic evaluation against HeLa cell line. Cancer is one of major public health problems in the world. Based on the data from Global Cancer Observatory in 2018, the three most common cancer in Southeast Asia region is breast, lung, and cervical cancer. Cervical cancer is the fourth most common among women worldwide after breast, colorectal, and lung cancer. Cervical cancer was also the fourth leading cause of cancer deaths after breast, lung, and colorectal cancer, with a sufficient number of cases and the number of deaths in 2018. Human thymidylate synthase enzyme, or HTS, is one of key players in DNA biosynthesis. This enzyme catalyzes the synthesis of the essential precursor required for DNA biosynthesis. Some studies reported that the high HTS expression has been correlated with poor outcome of several cancers, and overexpression of this enzyme has also been correlated to anti-cancer drug resistance. Then, in another study showed that the inhibition of this enzyme lead to the inhibition of cancer cell growth. Therefore, it's become interesting to target this enzyme in order to discover new anti-cancer agents. In this study, we are interested to observe the potency of a fluorinated irazoline analog, or compound 3, as inhibitor for cervical cancer with the aid of molecular docking study. Then, the in vitro evaluation was also performed against HeLa cell line. Compound 3 was synthesized through intermolecular cyclization between fluorinated chalcone with hydrazine hydrate in absolute ethanol with the presence of glacial acetic acid by applying the microwave irradiation. The molecular docking study of compound 3 was performed using molecular operating environment, or MOE, software package. Ligand preparation has been performed using ChemDraw Professional, Discovery Studio Visualizer, and MOE. This is the structure of two ligands. The ligand A is our synthesized products, and the ligand D is one of anti-cancer drug for cervical cancer, 5-fluorouracil. The crystal structure of HTS enzyme with active site bound to a thiazole derivative was downloaded from protein data bank with PDB ID of 4E2X and was prepared using BSP and MOE. The docking result was obtained as binding free energy in kcal per mole. In the last step, the ligand-protein interaction were processed by DSP and depicted in 2D and 3D view. In vitro cytotoxic activity assay against HeLa cell line was performed using MTS assay according to previous methods. This is the result of our work. Compound 3 was obtained as mild white solid with considerable yield and submelting point. The purity of the synthesized compound was confirmed by XPLC chromatogram with a single peak. The mass spectra from LCMS analysis show the molecular ion peak is matched with calculated mass of the compound 3. The proton NMR spectra was also measured to ensure the structure of the product. Overall, all the spectroscopic data agreed with the structure expected. The molecular docking study was performed to evaluate the potency compound 3 as inhibitor for XTS enzyme. In this study, we docked the compound 3 and 5-FU to the active site of XTS. Based on the literature, 5-FU can act in several ways, but principally as XTS inhibitor. Interrupting XTS activity will block the synthesis of a nucleoside required for DNA replication, then rapidly dividing cancer cell undergo cell death. This is the interaction of 5-FU with XTS. Based on the molecular docking result, 5-FU interacts with 9 amino acids residues of XTS. Both NX group of 5-FU interact with this residue and also this residue through conventional hydrogen bond formation. Based on the calculation, this compound has binding free energy of 2.6693 kcal per mole. This is the interaction of compound 3 with XTS. Compound 3 interact with 13 amino acid residues of XTS. This compound is able to form van der Waals interaction with 10 amino acid residues in the active site of XTS. The conventional hydrogen bond is not formed between compound 3 and XTS. However, the docking result show that the compound 3 has the lower free binding energy than 5-FU, which indicated that compound 3 has higher potency to form the binding with the XTS. The in vitro cytotoxicity activity of synthesized compound was determined using the MTS assay against HeLa cell line. The MTS assay is a colorimetric assay for measuring the cellular growth that involve the bioreduction of blue resazurin dye to red resorubin by living cells. The higher number of living cells in the test solution, the higher intensity of the red color form. The higher concentration of test solution show the lower intensity of red color form, which indicate the decreasing in the number of living cells in the test solution, as shown in this figure. Based on the result of in vitro cytotoxic evaluation on the table, it seems that compound 3 possesses strong cytotoxic activity against HeLa cell with IC50 27.56 microgram per ml. Compound 3 has higher cytotoxic activity than 5-FU and slightly lower cytotoxic than cisplatin. Based on this figure, we can observe that he morphological appearance of HeLa cell when treated with compound 3 showed the decreasing of HeLa cell number. It indicates that the treatment of compound 3 affected the HeLa cell growth. This result suggests that the compound 3 might be a promising agent for cervical cancer treatment. Okay, this is conclusion for my presentation today. Both of the results in silico and in vitro evaluation suggested that the compound 3 might be a promising agent for cervical cancer treatment. Thus, the synthesized compounds still need further evaluation success in vivo study and also the toxicity evaluation to ensure its safety and as anti-cancer agents. Thanks to Kemenristek Dikti for support and funded this work through Hibah Penelitian Dasar Unggulan 2020. And thank you for your all attention and see you.
Okay, thank you for Mr. Jasmine for the presentation. So now I invite you to start the discussion with Mr. Jasmine, please. Please?
May I ask?
Yeah, please, Mr. Miftahul Khair.
Okay, thank you. As you also use microwave for synthesis, I want to know about the power of 300 watts for 3 and 5 minutes microwave irradiation. Is it by optimum number, or how do you get this number, Mr. Jasriel?
Okay.
Yes.
Thank you, Mr. Miftahul Khair. We get the irradiation power to use in our work from some literature.
Okay.
Some literature reported that the irradiation power of 300, and some literature also reported for 450 watt. But some literature also have been reported that the optimal irradiation power can be used is 180 watt. But it is depending the instrument that you use because there are many microwave. So it is maybe can affect the difference of irradiation power is needed for the reaction.
Okay. Do you use domestic microwave or laboratory microwave?
In this work, we only use the domestic microwave. But in our lab, we have domestic and also microwave for synthesis.
Okay, thank you so much, Mr. Jasri.
Okay, thank you.
Thank you.
Yes, thank you for Mr. Jasri and Mr. Hoyer for the discussion. And now I invite another questioner, please. Another question?
I think for me, Sitoriza Sativa, sir.
Yes, please.
Mr. Jasril, my name is Sitoriza Sativa. Maybe my question will look simple for you as this is not my research background. You wrote on the conclusion that this research needs toxicity evaluation. And my question is, what kind of toxicity evaluation that need in this research for the safety of anti-cancer treatment? or maybe do you expect for the next project, if you have any? Thank you.
Yes, thank you. Hello?
Yes.
Hello?
Yes,
Uh,
Mr. Jasril, maybe you can respond the Miss Oriza Satifah's argument, I think. Please.
okay. Thank you, Mrs. Siti Oriza. We will continue our work to ensure its safety as anti-cancer, as you suggested. Thank you very much.
Okay. And I think it's also very interesting if the pyrazoline analog here, maybe Mr. Jasil looking forward for the coronavirus inhibitor, because the pyrazoline analogs also potential for papillomavirus oncoprotein, as you read right on your abstract. Do you have any future or plan of your research to the
Yes,
coronavirus?
of course, Mr. Hanhan. Our co-author also is working for in silico study for COVID-19 inhibitor to target the protease enzyme of COVID-19 too. But the work is not finished yet.
Okay, we will wait. We will be waiting for your next report about the antivirus of your pyrazoline analog. Thank you. So we can give applause for Mr. Jasril. Now I will invite next question. I'm sorry, next presenter, Mr. Ihsan, I think. Abstract 106.
Hello?
Yes. Okay, Mr. Ihsan, it's your time to deliver the presentation. Maybe the video will be played by the operator.
Okay, thank you.
Yeah.
Good afternoon, ladies and gentlemen. Thanks to moderator and all committees of the second Science and Mathematics International Conference 2020 for the time has given to me. I also thanks to Professor Jasril because he trusts me to present this paper. My name is Ihsan Estiarudin. I am from Sekolah Tinggi Ilmu Farmasi Riau Pekanbaru. Today I will present one of our research group topic. It is about microwave assisted synthesis and antioxidant activity of a hydrazone compound A1,4-methoxybenzylidene to phenylhydrazine. Hydrazones have been reported for various biological activities such as antioxidant, anti-cancer, and anti-tumor activities. This compound can be synthesized using various synthesis methods, include stirring, reflux, and also microwave irradiation method. Some studies reported that the microwave-assisted organic synthesis show a great virtue in the synthesis of many organic compounds. Therefore, for some researchers, this method is become a more attractive method compared than any conventional method. Antioxidant defense mechanism is required to prevent cellular damage observed in various diseases. A study reported that some new hydrogen derivatives possess a high antioxidant activity with low toxicity, and the antioxidant effect is similar to quercetin as a standard. In addition, the hydrazone also show the protective effect from cellular damage caused by ferrooxidative stress. Therefore, in this work, we are interested to synthesize a hydrazone compound by reacting penyl hydrazine with a benzaldehyde derivative under microwave irradiation, and then evaluate its in vitro antioxidant activity. This is the method for our work. The synthesis of title compound or compound 3 was performed by reacting of phenylhydrazine with 4-methoxybenzaldehyde in absolute ethanol under basic condition by applying microwave irradiation through a nucleophilic addition and followed by dehydration. And then the spectroscopy analysis include UV, FTIR, MS, 1D and 2D NMR were performed to confirm the structure of the product. Then the in vitro antioxidant activity was performed by DPPH method. The absorbance of test solution was measured by micropipette reader by slight modification from the previous procedure. The percentage of free radical scavenging activity or percentage inhibition was calculated using this equation. The IC50 value was calculated based on the linear equation obtained from the curve by plotting the value of learned concentration on the x-axis and the percentage inhibition on the y-axis. Then the potency of antioxidant activity is categorized based on the IC50 value according to the previous literature. Okay, this is the result of our work. In the introduction, I said that the microwave-assisted organic synthesis show a great virtue in the synthesis of many organic compounds because this method has some advantage such as excellent yield, short time, and also as a green approach for a synthesis of many organic compounds. But based on the literature search, it is not in every case. In this case, we only get a moderate yield, 60.22%. The product was obtained as yellow solid with sharp melting point of 110 till 111 degrees Celsius. The purity of product was confirmed by GCMS analysis with a single peak at retention time of 11.18 minutes on the GC chromatogram. Then the mass of the title compound on the mass spectra is found matched with the calculated mass of the product. In addition, the structure of product was also confirmed by 1D NMR analysis, include proton and carbon NMR, and the assignment for each signal on the both 1D NMR spectra were confirmed by 2D NMR analysis, include HSQC and HMBC analysis. Okay, this is the result of antioxidant test for the title compound. Based on the calculation of IC50 value, The title compound exhibited very strong antioxidant activity with IC50 value of 9.5 microgram per milliliter, and it is very close to IC50 value of ascorbic acid as standard antioxidant with IC50 of 9.45 microgram per milliliter. This is a solution for proton donor mechanism of the title compound. The title compound can donate its proton to DPPH free radical because the resonance in the conjugation system will stabilize the formed radical. In addition, the presence of electron donating group, in this case is a methoxy group, can also increase the stability of formed radicals through electron delocalization that induced by mesomeric effect of the methoxy group. This is conclusion for my presentation today. Methoxy substituted hydrazone has been synthesized under microwave irradiation with moderate yield. The spectroscopic data agree with the structure expected. Then antioxidant activity has been evaluated using DPPH methods. It's shown that the synthesized compound exhibited very strong antioxidant activity, and it is very close to IC50 value of ascorbic acid as standard. In addition, the in vivo evaluation and toxicity test is required to ensure the potency of this compound as antioxidant. Okay, thanks to Kemenristek Dikti for support and funded this work through Hibah Penelitian Dasar 2020, and thank you for your all attention, and see you.
Okay, thank you, Mr. Ihsan, for the presentation. And now I will invite you to start the discussion with Mr. Ihsan. Yeah. Please.
Han, I want to see. I want to
Yes.
question.
Yes, please.
Okay.
Mrs. Sri. Yeah.
Okay. Thank you, Dr. Han. Mr. Ihsan, I have two questions.
Yeah.
The first, could you tell me the mechanism of your compound as antioxidant? I see the last your presentation. Thank you. I see that. Okay. The second, could I making your compound as a standard if I do the if I measure my my product antioxidant, because I see the you tell me the activity as antioxidant the same as a quercetin. I think the IC50 then 10 microgram per millimeter. Okay, thank you.
Okay, thank you for Mrs. Sri for the question. Two question, Mrs. Sri.
Yes.
Okay.
Yes.
I will try to answer for the first question about mechanism mechanism of action of my synthesized compound as antioxidant, isn't it?
Yes. Yes. All right.
Okay. This is only a suggestion mechanism for us, from us, that this compound can stabilize the free radical by donating its proton to DPPH. So the DPPH will be reduced to the DPPH or diphenylpictorial hydrazine. This can be observed by the changing of color of DPPH purple to the yellow because the reduction process. Then the compound can donating its proton because the format radical of the compound can be stabilized by delocalization of electron. This is the answer for second question. In this work, we only evaluate the antioxidant activity of the synthesized compound only by DPPH method. We know that there are many methods for antioxidant evaluation. So if you want use our compound for antioxidant standard or positive control in your evaluation, maybe it is okay for the DPPH method, but for another methods, it is we should evaluate the result before we use as standard for antioxidant evaluation. I think this is my answer.
Yes, thank you. Do you have this compound?
Yes.
Do you have this compound?
Yes, I have.
Okay. Thank you.
Okay. Thank you very much.
Yeah, thank you very much, Mrs. Sri and Mr. Ihsan for the discussion. Yeah, I think your presentation time is up. Thank you, and we will continue to the last presenter, but actually it should be the break, but we still have another question, so I think it's better if we continue, then we finish the session. Is it okay, ladies and gentlemen?
Okay.
Okay. Yeah. Thank you. So now we will continue to Miss Nahda to start the presentation. Yeah.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. First of all, I'd like to introduce myself. My name is Nahda Zafira from Universitas Negeri Jakarta. Today, I'm going to talk about a simple and efficient synthesis of ancestor derivatives. Did you know ancestor? Ancestors are product of 1,4-dihydropyridine synthesis. German scientist Arthur Rudolf Henz first synthesized ancestor in 1881 from a multi-component condensation reaction between aldehyde, beta-ketoester, and ammonia in acetic acid or ethanol. Why do we need to synthesize ancestor? We need to synthesize ancestor because it's exciting and beneficial for our life. These compounds are important classes of calcium channel blockers such as nilotinib, amlodipine, and nicardipine. This compound has promising bioactivity such as an antibacterial agent, antioxidant, anti-tuberculosis, anti-inflammatory, anticoagulant, and anti-cancer. This ancestor has structural similarities with NADPH on the 1,4-dihydropyridine framework. Ancestors have also been widely used as a source of hydride in the hydrogenation transfer reaction. This study aims to develop a simple and efficient ancestor synthesis procedure and its application as a proton donor to reduce chalcone to hydrogel form. Research method. The subject in the study were sample of ancestors. The type of research is experimental research. The data collection technique used as an experiment observation. The data analysis technique in the study used descriptive quantitative analytic, which provides research results in the form of the spectrum, numerical data, and image analysis descriptively. The instruments used in this study are channel chromatography using silica gel from Merck and visualism through ultraviolet light. The vacuum used a Batcave vacuum rotary evaporator R124. Melting point are measured using the Stuart SMP10 melting point apparatus. NMR spectra recorded with an Agilent 500 MHz NMR spectrometer. The research location carried out at Chemical Research Laboratory Universitas Negeri Jakarta for testing sample of time carried out at NMR Laboratory of Department of Chemistry Institute Technology Bandung. General procedure for the preparation of ancestor. A mixture of 1 millimole aldehyde, 2 millimole ethyl acetoacetate, and 1 millimole ammonium acetate dissolved in 2 milliliter ethanol. After that, the finished reaction was monitored by chain layer chromatography. Then the reaction mixture is cooled down. After that, it was extracted with ethyl acetate and washed with sodium thiosulfate and sodium chloride. The obtained organic layer and the aqueous layer. Then the organic layer was dried with anhydrous magnesium sulfate. After that, the mixture concentrated under vacuum. Then the crude product was purified by recrystallization with ethanol to produce a pure ancestor. Then the melting point test is performed using a melting point apparatus and characterization using an infrared spectrophotometer, mass spectrophotometer, ultraviolet spectrophotometer, and NMR spectrophotometer. So let's move on to result and discussion section. First, we try to synthesize ancestor using the microwave method. The reaction is carried out by mixing 1 millimole aldehyde, 2 millimole ethyl acetoacetate, and 1 millimole ammonium acetate into a porcelain cup and irrigate it for 5 minutes. The result is that 1,4-dihydropyridine crude is obtained in tiny amounts and contaminated with many unidentified side products. Next, we synthesize the ancestor using the reflux method. Unlike the original ancestor synthesis method, which is done in 2 steps, this method offers a one-step synthesis with a 3-component one-pot procedure and several reaction modifications. A simple reaction is carried out by mixing 1 millimole aldehyde, 2 millimole ethyl acetoacetate, and 1 millimole ammonium acetate. Then it's refluxed in ethanol and monitored by chain layer chromatography until the reaction is complete. The result of the reaction can be seen in Table 1. For formaldehyde, a pure ancestor product of 31% was obtained for 6 hours. For benzaldehyde, a pure ancestor product of 30% is obtained for 7 hours. We are very sorry that we have not completed the synthesis of ancestor for hydroxybenzaldehyde due to some problems in data collection. The synthesized ancestor is a known compound and its identity is confirmed by comparing its spectral data with those reported in the literature. For example, ancestor compound product 7B characterized using NMR spectroscopy, which included proton NMR, carbon NMR, HSQC, and HMBC. The proton NMR spectra of the 7B compound saw 23 proton signals from the alkane and aromatic groups. Several peaks are characterized of 1,4-dihydropyridine compounds, as can be seen in Table 2. The carbon NMR spectra of compound 7B saw the existence of 19 peaks of carbon atoms that appear on chemical shift, as shown in Table 3. Analysis of the HSQC data saw the bond of one proton signal bond to the carbon signal. Based on the HSQC 7B spectrum, this compound has 4 methyl group, 2 methylene group, 1 methane group, 1 aromatic group, and 5 carbon quaternions. HMBC allows the detection of correlation between proton and carbon separated by 2 until 4 chemical bonds. The result of the HMBC spectrum measurement for 7B compounds can be seen in Table 5. Based on the analysis of proton NMR, carbon NMR, HSQC, and HMBC that have been compared with the literature data, the 7B sample obtained is a Hans ester compound. In conclusion, we have tried to develop a simple and efficient synthesis procedure. Based on the result and discussion, this synthesis method has several advantages such as simple experiment procedure, melt condition, avoiding the use of catalyst in acid, base, and metals, simplicity in the purification process, no byproducts, and low cost. That's all my presentation. Hopefully this research can be useful for all of us. Thank you for your attention.
Well, thank you, Miss Nahda, for the presentation. And now I invite you to start the discussion with Miss Nahda.
Hello.
Yes, please, Miss Lintang.
Thank you, Mr. Hanhan. For Nahda, I saw your conclusion, so I'd like to ask, why does the research Hans ester synthesis, right? You didn't use a single catalyst. Okay, that's all my question. Thank you.
Yes, please, Miss Nahda, to answer the question from Miss Lintang.
Yeah. In this synthesis of Hans ester research, doesn't use a catalyst. Based on Heider research in 2009, the main problem in using catalyst in Hans ester synthesis is the difficulty separating the catalyst from the product. In some cases, the catalyst separation process can cause the catalyst to disintegrate so that it cannot be reused. Thank you.
Okay, is there any comment or another question from Miss Lintang?
Okay, that's all.
Okay. Is there any question about the presentation from Miss Nahda from other audience, please? Okay, Miss Nahda, I think I should ask you about one thing. In your in your presentation, you use the domestic microwave, right, for the
Yes.
reaction. So is there any reason that why you obtain the many undesired product on your TLC? I think the TLC showed the many unwanted compounds. Yeah.
Sorry, pardon me.
Okay. Your TLC from the microwave reaction show that there's many undesired products, right? Do you have a
Yes.
reason why the microwave reaction show the undesired product?
Hello.
Yes. Did you hear my question?
Maybe because the work process is not clean, so it's contaminated with impurities.
Yeah. Okay. Because we know that reaction by microwave should be also directed to the many other reaction, right?
Yes.
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 Okay. Yeah. So you may it may occur that in the reaction happen in your microwave condition underwent the other reaction that you didn't know, I think. Yes.
Yes.
Okay. Thank you for all, ladies and gentlemen. I think it's over for this session, and I kindly ask for you to turn on your video so we can take a picture. Okay, thank you. We can take a picture together because it's virtual conference, so we couldn't take a picture, so we can physically. Okay, thank you, Miss Nahda, Mrs. Nurhani. I think we may take a picture together. Okay. Mr. Isan. Okay. Oh, Mr. Isan from the office, I think. Yeah.
Yes. You are right.
Okay, maybe we can start to take the picture. 1, 2, 3. Okay, I think one more. I think one more. 1, 2, 3. Okay, thank you. Okay, ladies and gentlemen, I think we need also to fill the attendance form. Attendance form will be shown on the chat or in this conference room. You can see the link there. Yes, please fill the form so we can record your attendance. Okay. This the link, or you can see the link on the chat in this meeting room. So please fill the ascension. Okay, thank you. If you have already finished the presentation, I sent also the picture of our session today on the chat also. You may post it somewhere. And thank you for your kind attention for this afternoon session. And see you tomorrow because we still have another one day conference tomorrow for the invited speaker and also the keynote speakers. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.